I better get my... Permanently. Oh, hello? Oh, great. Okay. Hey, we can start. Oh. Yeah, my talk this morning is called Robert W. Floyd in Memoriam, and it's kind of a different talk than I've ever given before. But I had a lot of fun putting it together. In fact, this is probably one of the easiest talks I'll ever have to give in my life because, well, as far as the computer forum is concerned, I think maybe a lot of you are interested not only in what's going to happen in the next few years in computer science, but how did we get to where we are today, especially how come Stanford is such a great place for computer science at the moment? And I think it's clear that the roots go back basically 40 years, and it's because of people like Bob Floyd, who died last September, that this place is so great. I see Bob Tarjan in the audience too, and Jim King and Barry Hayes and other students of Bob. Now. In my own life, I would have to say that Bob was without a doubt one of the very strongest influences on my whole career, probably more than any other person, and so that's why it's such an easy time for me to make this talk. What I'm going to do is I'm going to base my talk today on documents, so not my reminiscences of what I think I remember, but from actual. Things that I found in my files that were written at the time that these things happened, and I hope, so I had a lot of fun going through scraps of information, and I'd like to show you some of these things. I hope you enjoy it too. Now, the first, so let me see if we can get the. It's on the screen here. This is the first report that I can see what the first report that I found in my files came from 1960, which was before I ever knew Bob. In fact, this was 1960. I got my my bachelor's degree in June, and he was at Armor Research Foundation in Chicago, and this it's not really called Advanced Studies of Computer Programming. It's really called Advanced Studies of Computer Programming. But the copy I have is is very poorly reproduced. But this was a description and user manual for the Moby Dick program and debugging system. Moby Dick was a computer used by the Army, and I don't know very much about it, but according to page 73 of this report, the contract personnel, there was R blank. That's R.W. Floyd, and Bruce Kallick, and I forget. Was he the one who? Probably, I don't know. Anyway, and it said that they programmed the interpretation and debugging language, and then it says R.W. Floyd designed the logical syntax, and it's signed by Sid Schwartz. Anyway, now I learned later that Bob and I learned computer programming exactly on the same machine. It was an IBM 650. Bob started a year earlier than I did. He started programming the 650 in 1956. I didn't see such a machine until the summer of '57. But anyway, this might have influenced, been a reason why we got along later. But just to set the scene, I'll show you. Here's one of the pages at the end of this. Near the end of this report of subroutine 28 and here's assembly code. And I don't know if Bob. There were 3 programmers on this, so I don't know if this is Bob's work at Armor Research or not. But it shows the idea. You write in the machine instruction, and then you say, and then you a little bit of a haiku where you try to find a way to give a meaningful comment in 20 characters or less on each line.
I'd like the mnemonic name of the subroutine.
The mnemonic name of the subroutine inst type. Yeah. Okay. And then, in order to satisfy your sponsors in those days, you also present flowchart, which shows how you, which was supposed to explain what those lines of code did. Now, anyway, this just, the IBM 650 was a lot smaller and slower than the Moby Dick, but not that much. It was 8K of memory, and it was a 10 kilohertz computer, and 7 cycle times for an add if everything was positioned right. But if it wasn't, you lost 98 cycle times because the drum had to get around to it. And so those were the machines we started with. Now, then my first introduction to Bob was through his first major publication in the ACM Journal, 1961. Here again, you see that it's credited to Armor Research Foundation, and it was called A Descriptive Language for Symbol Manipulation, and this is where this became known as Floyd Productions later on, and actually I think had a lot to do with expert systems and things like that in future years. But in this article, he explained by a new notation what people writing compilers had been trying to puzzle over for many years. The people who had written compilers, there were about 40 different compilers written around the world by that time, but nobody understood really. It was kind of a miracle that the compiler would work. And so he had these productions which say if you have something of this form where this delta is your cursor, then you replace it by this and you do some generation rule. And here's the I found that I was a grad student at Caltech, and I was asked to review this paper for computing reviews, and I found the carbon copy of my review. I couldn't find that particular issue of computing reviews. Seems to be missing from my collection. So this paper is a significant step forward in the field of automatic programming. Over the past few years, simple algorithms for analyzing arithmetic expressions have been discovered independently by many people, but conventional methods for explaining such algorithms obscure the essential facts. Floyd has developed a new notation which lets the trees be distinguished from the forest, admirably points out what is really going on in the translation process. Algebraic compiler can be described very precisely and compactly in this notation. One can design such a compiler in Floyd's form in a few hours. Formerly, they were defined in the form of flowcharts or annotated assembly listings, so you see that even though Bob was at Armor Research writing annotated assembly listings and flowcharts, which I didn't even know when I wrote this review, his article in ACM Journal was a nice antidote to that. Then other notations appeared, such as T-lists at Carnegie Tech, transition diagrams at Case Tech, complete assembly language of Brooker and Morris at Manchester University. Now, Floyd's notation is at once more compact, more readable. The reviewer believes it will benefit automatic programming just as a switch from x dot to dx dt has benefited work in the calculus. And so then I go on to explain what his productions are. Now, so as I said, I hadn't met Bob at the time, but I did start to appreciate his work. It happened that in the summer of 1962 I was finishing up a compiler. Was it 62 or 60? no, it was 63. When did I finish my compiler? I think it must have been 63. Anyway, I spent the summer writing a Fortran compiler and finished it. It was an intensive. It was an intensive project for a year, for 3 months actually. I'm not sure if it was 62 or 63. Anyway, we could date it by there was an ACM national meeting in Syracuse in the fall, and Bob was a presenter there and so I met him and we talked for a long time I'll say a little more about the things we discussed, but we found that we had lots of interests in common, and so it was at that time that I really could put a face to the person whose papers I was reading. The first letter that I have in my files from him is dated, however, October 63. That's why I'm not sure if it's 62 or 63 when we met. And I had evidently written to him about something called TTLs, which I'm not sure what they are. Some kind of languages. Some kind of anyway. It was it had to do with something like context-free languages, but another formalism that has died out. Then I had asked him, but we were interested in ambiguity because as I was a grad student at Caltech, my first idea for a research project was to look at the problem of context-free languages and find out what grammars and see whether they were ambiguous or not, whether or not you could parse a string in two different ways. And I didn't know that the problem had already been proved unsolvable. But I asked Bob about a special case of the problem, which was whether, in modern terms, we would say whether a finite state language could be whether a simple finite state language could be decided whether it's ambiguous or not. In particular, I just said, what if we had a set of strings, and then we just allow any number of copies of those strings, like so say you have B, A, B, and A, and then you say make any word that you can by repeating one of these four and then another one of the four and so on. Is there a unique way to decompose that into the ones you started with? And I didn't know the answer to this problem. I mentioned it to Bob, and he replied with an algorithm for, explaining how to solve that particular case of the ambiguity problem. Well, we both found out soon afterwards that this was a well-known algorithm due to Sardinus and Patterson in 1952. But it just shows the kind of things that we were talking about in those days. Here's a letter that I got from him in February of '64, and I think he wrote it the day after I had visited him at his house in Topsfield, Massachusetts. By that time, he was working for Computer Associates Incorporated, actually also in the previous letter, and I remember we talked about a lot of technical problems that I had just learned about the sorting method that became known as heap sort, but I also showed him a problem related to sorting networks, and I had noticed a curious thing that if you start out with numbers in reverse order, 7, 6, 5, 4, 3, 2, 1, and you alternately swap the things that are even positions, then you start over here, then you go this way, this way, this way, this way, this way, and you keep on swapping them n-1 times, you get you get the things in perfect order, and so Bob said about that sorting system you showed, I find any sorting procedure by interchanges of adjacent lines will correctly sort all inputs if it will correctly sort an input that is in in decreasing order. So he vastly generalized what I had told him, and he also gave on the next page he gave this lemma, which was a stronger result that he could prove. Now this I can show you from volume 3 of the Art of Computer Programming that this has now survived in on page 240. R.W. Floyd, 1964. So a network that involves only adjacent comparisons of one number and the one after it is called primitive. And so Floyd proves that if this is his lemma from the letter I showed you, and then you get a theorem. A primitive network is a sorting network if and only if it sorts the single vector of the numbers in reverse order. So in other words, if it can sort that one permutation, it'll sort every permutation, provided it has this property. It's a beautiful result, and he said, "Was this the theorem you wanted me to find? Ask me another." Yeah. Well, it wasn't the theorem, So it was very nice. Now 64 was. I have a whole bunch of other mail from him in 1964, and at first he in February when I started talking to him, he got interested in this idea of sorting networks, and there was a paper in the ACM journal by Bose and Nelson. R.C. Bose was a distinguished statistician at North Carolina, but Nelson, both of them happened to have been teachers of mine as undergraduates at Case, because Bose spent a year at Case during my senior year, and they had found sorting networks that were pretty good, and they conjectured that they were optimum, and so they presented something that would sort n elements by what we call an oblivious manner, which means you have a little module that says compare these two and put the maximum on this line and the minimum on this line, and you try to find a sorting network that has the smallest number of modules. And Bose and Nelson had the best known construction. However, Floyd had found by the end of February a way to improve their network for sorting 21 elements, and he had reduced the number of modules from 118 to 117. So this proved that the Bose and Nelson method wasn't optimum, but the question was, can you do better? And he had sent a copy of that to me, and then also to Bose. Now he writes to Bose and remarks as now he can do nine items in 25 instead of 27. So here was a big improvement, really, relatively speaking, because here you're doing only 9 elements. Well, now it's been proved since then, by the way, that Nelson method is optimum for everything up to 8 at least, and the best sorting network for 9 elements is still unknown. But 25, nobody's been able to beat this 25. Maybe computers are getting fast enough that we could actually prove that Floyd's construction is the best. But it's a massive computation to try all sorting networks. But here he proved, and here's Bob's construction for 9 elements, which he presented with a certain notation, which then he explains how this leads to a proof. And so then I wrote to him a few days later saying, "Dear Bob, I was quite impressed, indeed awestruck, etc., by the example you sent me last week showing improvement of 2 steps in the fixed comparison sort for 9 elements. The first example, improvement from 118 to 117, was interesting, but certainly not nearly as remarkable as this. Therefore, I lost another day from book writing as I pondered this question anew." Bill mentioned, Bill mentioned that he's still waiting for the other volumes of the 7. Well, in 1964, I was thinking, I was trying to finish all 7 volumes before my son was born, and he was born in 65. I mean, and I still sort of feel this way that I'm about, I'm getting closer. But anyway, so I say, here are a few results I obtained today. I hope you check them for accuracy. I also hope you're inspired to find bigger and better improvements. And so then I talked about things. I had some diagrams of my own. I went to and here I went up to sorting 16 elements, and I used a 4x4 where he had used a 3x3. You see, so I generalized his method a little bit, and I was able to save over the Bose-Nelson method from 65 to 64, which was you might not say is very exciting, except that the Bose-Nelson method was at its best for powers of 2. The Bose-Nelson method sort of, its maximum efficiency was in the case where you had all even. So 16 went to 8 was based on 4, and so on. Those all looked like they were. If it was going to be optimum for any method, it would probably be for the powers of 2, and it wasn't. So anyway, here it went. So then Bob writes back. It says, very pretty. Now generalized to 3-dimensional diagrams. Okay, and so then so now this began a long correspondence on sorting networks that lasted over quite a few years. I think there were 3 or 4 dozen letters all the time, and every time I would get a letter from Bob, I would have to take another day away from book writing, as you say, because I mean, it was kind of a one-upsmanship. Each one of us. He might have felt the same when he got a letter from me, but then now now Don's ahead again. So he's got it. But anyway, this gave me an insight into really looking at scientific correspondence of other that you can find in the library where Leibniz is writing to Bernoulli or Euler to Goldbach or Gauss to Schumacher and Jacobi and things. That is now I'm not saying that Bob and I are in the league with these great mathematicians, but still but it was the same kind of a flavor that must have been true in those past centuries when people were exchanging their scientific mathematical discoveries back and forth, and so really I can't quite express how this enthusiasm that we had for that was caused by these challenging problems back and forth and finding beautiful patterns.
I'm just curious about the way you wrote these things. I mean, did you write drafts of these letters first and then type them up, or did a secretary type them up?
Well,
this seems so different than the way we work today.
Yeah, right. Yeah, there's no secretary's name here. Well, I don't know how Bob worked, but in my case, my letters. This is obviously something I wrote myself on my own typewriter. I recognize this is the font. I had a typewriter at my home that I know. I bought an IBM Selectric typewriter for $500. The people in IBM Los Angeles office said I was the only person they knew who bought it for use in his own home. But anyway, had a good touch. But I certainly wrote this on my own typewriter that I recognize. Other ones I know. You can see the secretary's initials at the bottom, but Caltech was not known for the quality of its secretaries. I must say that's one of the reasons I came to Stanford later. But yeah. So like the thing that I showed you from my computing reviews, that was obviously a draft that I did, and I put carbon paper in my machine, and when I wrote in the symbols afterwards, I didn't get perfect alignment in the carbon paper with the original, but yeah, this was the way we did, and you'll see others letters written in longhand coming up. Yeah. Okay. So anyway, by the way, a lot of Bob's letters show that he had a lot of power in calculus and quantitative mathematics that you don't see in his publications, but it was always part of his thing. Now this is the next thing I want to show you is one of the greatest papers I think ever written in computer, and certainly in the compiler field. Now, in the 60s, you have to remember that the computer science had it was sort of divided into 3 parts. And and there was almost nothing else really as far as what was done in the CS department. You had numerical analysis, you had artificial intelligence, and you had programming languages, and this was sort of it was carved up into these three areas, and this was the masterpiece of the programming languages area. But Bob surveyed the field, and in this paper, he added. It wasn't just a survey, but he put the whole thing into order and provided a brand new idea, which I want to show you quickly here, if you can hear. He talks about a new way to proceed parsing algebraic language, and he says this analyzer makes use of a complicated hierarchy of subordinate goals in seeking its principal goal. So we introduce it with a metaphor. Suppose a man is assigned the goal of analyzing a sentence in a phrase structure language of known grammar. Now, this was in the 60s, you remember. Now we would say a person, but anyway. He has the power to hire subordinates, assign them tasks, and fire them if they fail. They, in turn, have the same power. Every man will be told only once, try to find a G, where G is a symbol of the language, may thereafter be repeatedly told, try again, if the particular instance of a G that he finds proves unsatisfactory to his superiors. And now, it turned out that this is a brand new control structure, which now we could call recursive coroutines or threads. Anyway, I think this is in some senses the birth of object-oriented programming. The idea that these people retain their state, and so the person is hired, but then he gives a report to his superior. But the superior says try again, and at this point the man retains all of the stack and everything that he knew that had gotten him to this point. And it was an unknown control structure in programming at the time, and it was why Bob was able in this, not only in the survey, but to present a brand new method that didn't have bugs in it for the first time, because other people's methods using old control structures would break down on complicated examples. Now here's a handwritten letter that I wrote to Bob. It's from a 10-page letter written at the end of '64, and I had just at that time been finishing my chapter on the first draft of my chapter 10, which was on how to parse, how to write parsers for compilers, and I had in the previous pages of this letter I had sketched out what later became known as LR of K parsing algorithm, and here it says, I must apologize for the complexity of my construction. Indeed, it is too complicated to put in my book. Now, of course, when I finally do get around to having chapter 10, I'll have to start with LRK parsing, because that became an industry in itself, in Yak and all these other things based on it. But at this time, it was so complicated, I didn't, I figured it was way beyond the scope of a book. Anyway, this seems to be inherent in this problem. I know of at least 3 PhD theses that were entirely concerned with only the most simple cases of parts of this problem. And then it says, as I go further into chapter 10, I become more convinced that only 5 really worthwhile papers on scanning techniques have ever been written, and you were the author of all 5 of them. Okay, and I think anyone who studies the early literature of programming language will come to that same conclusion. Then I say, however, I wish you hadn't come up with the quote proof unquote that algol 60 can't be defined in Backus-Naur form. All you proved was that certain semantic restriction couldn't be expressed in. Anyway, we got into some debates also at this time. Now, the next paper I want to show you, a major paper that came out in '67, but it was really in Bob's thinking all the way through here, called Assigning Meanings to Programs. And this is really Bob and I talked about a huge number of interesting algorithms over the years, But the thing that I really learned most from Bob was, and what really changed my life, was that he was the first person who showed me, who connected the mathematical and the programming parts of my life, and showed me that programs could actually be proved correct, not just understood. And you know, the prevailing wisdom, and for you know, up until the 60s, almost 100% of all people writing computer programs would never think of that as having anything to do with proof. The program you would hack away. You would write it, and you would twiddle. You would massage it. You find a bug. You'd remove the bug. You'd patch it until it worked. Until you couldn't make it fail. Or you come to a point where you say, "Yeah, I think I understand." Although you know, people like that wrote some of the early compilers told me that they lived in dread that the next day somebody would come up with a statement that wouldn't parse correctly. You know, but all the way through in programming, we had one. We never thought. I mean, the question of how do you know it's right didn't even enter our heads. It was not. It was just not a concept. On the other hand, you know, I was a programmer, and you know, did consulting for Burroughs and things like this. But then I would also go in and be a mathematician. In mathematics, I would prove things. And but what Bob was the person who showed me that really I could prove things about programs as well. A complete revelation that this could be done. And one of the pioneering papers then was this about what's now called Floyd assertions or something like this, assigning meanings to programs. And what he showed is that basically you could if you have a program represented, say, by a flowchart, you could decorate it by assertions that are true at this part of the program, and you can show that if this is true before the step, then this is true afterwards, and you can sort of prove by induction that you get the right answer because every step of the program preserves the things that are true before and after that step. And this became, of course, another big industry, and many great advances over the years on this. But I think Jim King's thesis was related to this work, right, Jim? So now. And that was done at Carnegie, where Bob was at that time. You see at the bottom of this reprint here. Now I want to show you one other letter from that time. Is that I wrote in '67. This I wrote to Myrtle Kellington, executive editor of the ACM Journal in Communications. She was in charge of getting all the papers into print, and she was really. I had great respect for her, and wrote a long tribute to her when she retired many years later, because she was faced with a completely new technical field and how to establish good typographic conventions. She was largely responsible for the way, for example, Algol 60 programs got typeset with boldface in certain ways and things like this, and the structure that came out. They had to wrestle with this problem because computer science had new problems of formatting that other fields hadn't faced before. Now, but here I was editor of the ACM Journal section. I forget which section it was, probably programming language section in '67, and I said, "Dear Myrtle, you sent me 3 letters in May while I was abroad, all dealing essentially with cutting publication costs. I was unhappy to read of your decision to make Floyd submit Leroy-lettered flowcharts for his article, especially since I had no chance to communicate my feeling to you. I was in Europe for 3 weeks. You said you could not authorize the printer's art department to prepare figures other than under exceptional circumstances. Well, I feel this case presents exceptional circumstances. 1, Floyd's article, perhaps more than any other article I've ever seen, is based almost entirely on illustrations coordinated with text. To such an extent, the effectiveness of the article will be considerably degraded if typeset text is not used in the diagrams to match the printing in the main text. Saying that he should prepare his own diagrams is in this case like telling our authors never to use mathematical formulas unless they submit hand-lettered copy for them. 2, Professor Floyd has been one of our best and most faithful referees in the ACM publications for many years. He has volunteered much of his valuable time to this often thankless job. Now he is an associate editor of JACM. We certainly owe him a decent treatment of his article. And so then, since your letter of May 10th gave him a deadline of May 25th, I presume he has already been obliged to have the new flowcharts made up. Here I'm writing in June. I believe we should at least paste typeset copy into the drawings he has supplied. By the way, I was careful to mark in the manuscript I sent you all the copy to be italicized with blue underline. Floyd does not have access to this information, which in several cases involves some situations where italics and Roman were mixed in a way we could not anticipate when he sent the drawings to you. He could not, so I hope you can adhere to the way I marked it up on your unique copy. So anyway, I'm giving her all this. I'm quite surprised that you feel you must be so stingy at a time when several publishing houses are starting up new journals which have no page charges, presumably as a profit-making venture. The Journal of Combinatorial Theory, Academic Press, recently made up 6 illustrations for me in a short article I submitted to them. How can ACM be going broke, especially now that dues have gone up 40% again? I'm certainly all for cutting costs, but not at a great sacrifice in quality. By the way, Academic Press has recently been bought out by Elsevier, and I'm now fighting the battle on the other side. But that's another thing. Now, by the way, here's I had to work on typography later on in my career, as some of you know. And here it says, turning to another topic, I agree with you that the typewriter style of type used in June '66 communications was rather ugly, but mostly because it was too big. The publishers of my book have found a very nice typewriter font that looks fine even when mixed with Roman and italic, as you once told me was impossible. So I think I was correct in raising the matter with you 18 months ago. And so on. Anyway, we were talking about typographic issues already in 1967. But I'm glad to see that Bob's article, which was another famous article in the ACM journal, this is called Non-Deterministic Algorithms, where he presented a paradigm that's now been used, in many actually programming languages have been based on this. You can look at the diagrams, and the ACM did paste in, typeset these fairly close to match his thing. So at least that they did follow through on. Now, Bob was asked to be by Addison Wesley to be the reader for the Art of Computer Programming, before publication, and I had finished chapter 1 of this. Which turned out to be the first half of volume 1. I finished chapter 1 in the summer of 1965 when my son was born, and I at least finished chapter 1, and they sent it off to Bob for his review. And here's his the comments he made to the first draft of it that were done in this summer. He says, I like the chapter, but I think it could be improved by chopping most of the humor and anecdotes. I don't know. I think I probably chopped a little bit of it, but anyway, retain the historical material. And then he says, sections I particularly liked included such and such, and I was least interested in 126 and 128. This is binomial coefficients and Fibonacci numbers, actually. So anyway, he said the system of rating problems underestimates their difficulty for, say, college seniors, and it designates too many with the arrow that recommends a particular exercise. The author's personal notes of advice are often valuable at times, so the non-technical material gets a little thick. And so then he goes and gives a detailed critique. Where, like some of you know, the beginning of volume 1 has a flowchart saying how to read this series of books. He says, I don't like this flowchart, nor the humor generally. The book is sufficiently advanced that sugarcoating should not be required, and this takes up 3 pages of space. Okay. So, he gave very detailed comments on things, gave better answers, solution to some of the exercises, again, you can see how helpful he was to me at this critical stage in my life. Here's a letter that I wrote. Actually, it doesn't show up here. It was February 1967. Bob, I have a feeling this is going to be a somewhat extraordinary letter. During the last year or so, I've been getting lots of offers of employment from other colleges. You see, I'm at Caltech here. I think I told you that I plan and have planned for a long time to decide on a permanent home where I will want to live the rest of my life and to move there after the year I spend in Princeton working for the government, namely to move in September '69. Due to the present supply and demand in computer science, I'm fortunate enough to be able to pick just about any place I want to go, but there are several good places and it's quite a dilemma to decide what I should do. I believe the 4 places that are now uppermost in my mind are Stanford, Cornell, Harvard, and Caltech in that order. I expect to take about a year before I make up my mind with Jill's help. It occurs to me that I would very much like to be located at the same place you are if this is feasible. At any rate, your plans have a non-trivial place in the nonlinear function I am trying to optimize. I know you don't like Southern California and I don't like Pittsburgh, so if we are ever going to get together, it seems Cornell or Stanford are the most likely places. I spoke to Hartmanis and Forsyth about the possibility of making an offer to you at the same time as to me, and both seemed to think this was an excellent idea. So anyway, I would like to explore it. And so I wrote to him this letter, and Bob's reply comes longhand, which means that maybe they were being typed by secretaries. Says, about your last letter and off the record, so maybe I shouldn't read any of this. I tend to agree with your decisions. My attitude about the universities in question is this. Okay, so then he goes on and rates all the people. You know, I mean, should I read this? Harvard, rather weak in computer science now with Salt and Wang and Fisher gone. Very limited opportunities for promotion to tenure, which is why they lost Fisher, a great university, but not promising for any new and growing discipline. MIT will be very good if they give computer science a home of its own. And so on. He goes, and then Stanford, one of the best faculties in computing, a very great university in a beautiful part of the country. The only problem is that they are overloaded now. They have 120 students, while Carnegie is going from 35 to perhaps 50 this year. From what Perlis tells me, it might be best to let this get worked out before going there, though they may be able to do so quickly. I understand that lack of space is also a problem. Some students are quartered several miles from the department. Next page, we don't plan to spend the rest of our lives in Pittsburgh, though it's not a bad city. Right now, Stanford looks like the best choice, and the Bay Area would be a great place to live. I'd say if you want to make the move, I don't have any plans that would conflict, and I will be very tempted to go to Stanford myself. I probably will go, in fact. So that was what Bob wrote to me in February of '67. I found also the letter of recommendation that I wrote for his application to Stanford. I'm pleased to be able to write a letter for Robert W. Floyd. I don't know anyone I could recommend more highly. He's the most gifted man in his age bracket that I have ever met. Several of his published papers have been significant mileposts in the development of computer science, notably his introduction of precedence grammars, which I didn't mention so far, three-sort algorithm, methods of assigning meanings to programs. I've also had the pleasure of carrying on frequent correspondence with him for 5 years. I'm quite familiar with his unpublished work, too. This correspondence covers a wide variety of topics, for example, graph theory, word problems in semigroups, mathematical notations, algorithms for syntactic analysis, theorems about languages, algorithms for manipulating data structures, optimum sorting schemes, etc., etc. While I was editing the ACM Communications and Journal, I asked him to serve as referee for several papers. It was not uncommon for him to submit a 4 or 5 page review containing important suggestions for improvements. He has a good record working with students at Carnegie on both the undergraduate and graduate level. By the way, not only was Jim King his PhD there, but also Zohar Manna and Jay Early, among at least. He's one of the rare people who have considerable experience and expertise both in writing computer programs and in developing useful theories related to programming. This is a key thing. You had people who were theoreticians but never was set foot in the computer room, and vice versa. Never think theory. I think he was the first person to suggest that compiler programs should be proof correct, not just debugged, to develop means of making such proofs. This was the real contribution of his paper on precedence grammars. It was the birth of the theory of practical syntax analysis. Since von Neumann's time, the idea of proving the correctness of programs had been almost entirely forgotten. Floyd had been extremely influential reestablishing this principle. He's a true computer scientist with capital C and a capital S. His special talents seem to be A, the ability to devise ingenious algorithms, combinatorial constructions, B, the ability to develop non-trivial new theories that are both of practical and mathematical interest, C, ability to organize a large body of loosely connected material to perceive the most important ideas, D, a talent for good exposition, for finding just the right words to express an idea. His only fault, known to me, is that he is sometimes a little too sensitive, too much the perfectionist. For example, although he has lived in the East nearly all his life, he has already decided that no California wine is worth drinking except BV Beaujolais. One further remark is perhaps necessary, considering contemporary standards of society, unquote. Floyd has never gone through the formalities of obtaining a PhD degree. I believe this was due primarily to the fact that he entered graduate school at the University of Chicago when he was only 16 or 17 years old as part of an experimental accelerated education program. This was not a mature enough age to do graduate work. Certainly he has written at least a dozen papers by now, each of which is superior to any PhD thesis I have ever seen in computer science. So the mere fact that he has never formally received a degree should be quite irrelevant. In fact, Bob used to tell me that he was going to get a PhD by the green stamp method. He had understood that if he could collect 100 letters from people addressing him as Dr. Floyd, that there was some university in Arizona that would give him a degree. I wanted to find a picture of him from the 60s when most of this took place, but I wasn't successful. But I think outside, actually, on the first floor, there's a picture that goes back earlier than me. But this one comes from 1972, and actually, you can't really zoom up any closer on this, but if you could really look at this close, you would see that this photo was done on an inkjet printer using the Floyd Steinberg method of making halftones, which is quite appropriate. So about this time, 1972, is when Bob came up with his method for making halftone pictures out of pixels, and it's of course now in common use as in software. And for Bob's former students who are here in the audience, I have extra copies of this picture to give. Continuing on, how am I doing on time? Good. Okay, so here's a letter that I wrote to the American Academy of Arts and Sciences in 1974. The American Academy, elects as fellows leading people in both the humanities and sciences, and they had asked for comments on members, and saying when considering computer scientists, it's difficult to rank them with respect to mathematicians, physicists, etc., since computer science is so young. A mathematician like Lema or Poya has been producing high-quality work consistently for 50 years or more, and this is much more than a computer scientist could possibly do. This makes it easier for computer scientists like myself, and perhaps it's too easy to become a fellow. I think I had just been elected as a fellow of this organization. Anyway, on the other hand, there are outstanding mathematicians like Bellman and Thomson whose work spans only 20 years or so. That is closer to what a leading computer scientist, say 15 years, would have to his credit. I will list the two candidates who are generally recognized as leading pioneers and whose names are household words, whose contributions span a broad range of topics as well as a long span of time, consistent quality. Edgar Dijkstra, who is responsible for more landmark contributions in non-theoretical aspects of computer science than any other man, namely the current revolution in programming methodology, fundamental principles of synchronizing cooperating processes, method for implementing recursive processes, as well as important algorithms. Such aspects of computer science are the hardest in which to make fundamental breakthroughs. He is also a able theoretician. Robert Floyd is the second person who is responsible for many of the leading theoretical ideas of computer science, as well as chairman of what I think is the leading academic department, mine, but I'm trying to be unbiased. His work is cited more than twice as much as any other person's in the series of books I'm writing, summarizing what is known about programming. His fundamental contribution to the syntax and semantics of programming languages, to the study of computational complexity, and the proofs of program correctness have been a great influence for many years, and he has also invented dozens of important techniques that are now in common use. So you see this a few years later, now using different terms to describe why Bob is a world leader, but it's clear that these things are really founding large areas of our field. I wrote to the Guggenheim Foundation the following summer. I don't know if Bob got a Guggenheim or not, but he was chair of our department for 3 years, and then he's entitled to 2 years of sabbatical, which he took at MIT, and so I imagine he was supported by Guggenheim at least one. Anyway, here I'm saying Professor Floyd is one of the most outstanding computer scientists in the world. In my mind, he's one of the top 3. During his career, he has been a leading light in the development of many of the key concepts of our discipline, and here I say a production language to describe algebraic parsing techniques now called Floyd production, notion of precedence grammars, semantics of programming languages, automatic techniques for constructing computer programs and proving their correctness. Each of these contributions has essentially created an important subfield of research later pursued by hundreds of people. Besides this, he has invented many algorithms of practical importance, for example, to find all shortest paths in a network, to sort numbers into order, to find the median of a set of data. Has several landmark theoretical papers that show certain problems are intrinsically hard. Examples of this I can cite his recent discovery of the fastest possible way to add numbers. This result meant that he had to invent an addition procedure that was faster than any others heretofore known, and to prove that no faster method will ever be possible. Both of these were non-trivial innovations. In my recent book that reviews what is known about sorting and searching, his work is cited 20 times far more than any other person. In fact, I can sort of show you that from the index here to volume 3. Yeah, can you see here? So you see that now Fuanta actually is not. This is mathematics, not computer science. But Floyd is way, and also half a dozen times in each of volumes 1 and 2. So this is his published papers show an amazing breadth, especially when one realizes so many of them have been pioneering ventures that became milestones. I'm sure that whatever he proposes to do during his sabbatical year will be of great future value to science, so I heartily recommend support by the Guggenheim Foundation. Now, during the time Bob was chair of our department, one of the big issues that he had to face, besides the the normal things about a growing department, was that we had a chance to have a new building and to bring the department together under one roof for the first time, and became in Margaret Jacks Hall. A lot of you remember that was right at the center of campus, not in the center of the quad. And here's a memo that I wrote in December of '75 when we were still looking at all kind of blueprints and so on, and I just said, thanks for all the fine work you've evidently done together with the architects for the new building. This will have a lasting payoff. We all owe you a huge debt of gratitude. In fact, Bob took the aesthetics extremely carefully and worked with all of the and worked in detail with the architects. Spent an incredible amount of time on it. Here's a letter that I wrote to him at MIT in '78, November '78. The faculty had his first chance to walk through Margaret Jacks Hall yesterday. Building has taken shape nicely. The roof is finished, so the winter rains, if we get any, won't be a problem for the workmen doing the finishing. Carpentry work is super quality, and the spaces are nice to walk through and be in. So I'm writing to say thanks for all the energy you contributed towards the success of the project. Thanks from all of us. And now, as it says, P.S. I'm enjoying the telephone poker game that Reves told me about. Yeah, this is another topic. Anyway, so Bob, has contributed not only to the pure scientific things, but also as a public servant and administrator and doing nitty-gritty things. Here's a picture that's in the Stanford News Service had from 1976, which was a period when he was chair. I tried to find it on this had a internet address, but it's not online anymore. But I got this from somebody, and it's another good picture to show. It gives the feeling of those days. Here's a letter I wrote at the end of his chairmanship. Thank you to the end for the outstanding services you gave our department as its chairperson these last years. You focused on and solved the critical problems facing us, and the present and future strength of our department is due in large measure to your efforts. Effects will last for a long time. Not having the energy to be chairman myself, I'm doubly grateful that you sacrificed so much of your time to these important tasks. Here's I have a picture from 1979, which is when he came back from there. But unfortunately, it was taken. This was a picture from the photo board at Stanford, and probably taken by a student who was not good at focusing the camera. But anyway, it's kind of an attractive picture anyway, showing him in front of his office at Margaret Jacks Hall. I mean, this was the corridor, I think, where I had it. Now, let's see. I neglected to mention two things from the early days. One vivid memory is from 1969, the day that President Nixon invaded Cambodia, and we decided that to go on strike, and this was sort of the last straw, and so we did it. So Bob and I and joined a lot of other students, and I don't know, probably a few other faculty, picketing Pine Hall so that nobody would be able to get into the computer center in those days. And we, of course, we knew that the only important thing was the statistics that would be reported as to how many people picketed, and so we sat there talking about sorting networks to each other. You know, we were saying, you know, no business as usual, but in fact we were still doing computer science as we were sitting there picketing.
What was the connection between Pine Hall and Cambodia?
Pine Hall was the computing center, and so there was, and so we would just say anybody wants to come and do their homework in computing, you know, to run. I mean, you had to punch card, you had to submit your cards in Pine Hall to get your program run. So we just prevented anybody from going into Pine Hall. And this was, but the whole campus was, you know, we said no, you know, we're not going to teach classes today. This was 1969. Stanford was, they torched Encina Hall. You know, it was quite an interesting place, time to be at a university. When we would give lectures, I would draw a square root sign to show that you know that I was supporting radicalism. You know, you know, say, you know, well, let's talk computer science because it's cool, but let's remember, you know, that the world is having problems with stuff like this. Another thing from the early days, Bob inspired a problem seminar which was given to entering graduate students, and this would be the students would work in teams to solve mini research problems, 2 weeks per problem, and extremely important part of many people education. So many of our students have come back and said that this was the thing that the class that they learned the most from. And Bob pioneered this class. He took it over from George Forsyth, who had learned similar things from George Polya, but Bob really was my model for it, and then he and I alternated teaching it for a while. So that's another thing I wanted to mention. Now getting towards later years, in the 80s, I was working mostly on typography, although Bob and I did do a joint paper about something we called addition machines. And I had found a note in my diary saying that in 1985 we had a long talk. It doesn't say what about. And then afterwards we went out to see Woody Allen movie The Purple Rose of Cairo. In 1989, Bob and I went up to San Francisco to see a play called Breaking the Code, which was about Alan Turing. And I think you know that Bob won the Turing Award, which is the highest award of computer science, and that was in 1978. And so his Turing lecture is in this book about the main lectures, and I reread it yesterday, and I was glad to know that actually one of the paradigms that he talked about in his Turing lecture involves some ideas that he said in the last time. He would say he would like to have. He says. Well, In most current languages, one could not present the main program procedures and data declarations in this order. Some preliminary human text shuffling of a sort readily mechanizable is usually required. Further, any variables used in more than one must be global and things like this. He says that the detailed breakdown of a problem into a hierarchy of procedures typically results in very inefficient code, even though most of the procedures are being called from only one place. Could it be efficiently implemented by macro expansion? Well, I was really struck by this because it turned out that this is what is why one of the main reasons I like C-Web for my programming now. When I came up with literate programming, I hadn't sort of realized that Bob had anticipated the idea in his Turing lecture. Let's see. So as I say, in '89, we went to see this the play about Turing, and we talked to the actor afterwards, mentioning our own connection to Turing. When Bob retired in 1993, he had his book had come out with Richard Bagel. This was really summarized many of the ideas that he had worked on in his life. Just a part of his life, really, that I wasn't personally very much involved with, except in the early days when we were talking about connections between automata and programming and languages. But I remember that that Bob had one of the last times I ever spoke to him. He had just received the translation of this book into German, and he was so extremely happy that that was not only translated but also a very good translation, because Bob had had been taking Stanford courses in advanced courses in German literature and so on. So he could really appreciate the German language. I guess I also could mention that Bob and I often would go hiking. We went one time to the desert. We went once. I remember he introduced me to Cove State Park in the East Bay, and so we would often talk about science and on those things. So you see, I have lots and lots of memories. And here's the last thing I want to show you is I'm sorry, I got one letter I wanted to find, but I couldn't find in my files. But I know I had it. I know I had it 15 years ago. So somewhere here said I had. This is my book on mathematical writing, where for one quarter I talked to students about how to write technical articles, and I showed a letter from Bob Floyd. The letter opened by saying, "Don, please stop using so many exclamation points." Exclamation point. And then he said, and he started. Every sentence had more and more exclamation points. And he says, "This is making me sick!" Exclamation point! Exclamation point! Exclamation point! And so I took a lesson from that, and I looked in the Art of Computer Programming. I found about 2 exclamation points per page, and so I realized I completely changed my style after that point. And I wanted to show you that letter today, but I haven't been able to retrieve it. Somewhere in my files it is. But the last thing I want to show you is this. My own papers are being collected, and there's going to be 8 books, God willing, when they're all done. And 4 of the books have been published already. For example, the Selected Papers in Computer Science. I dedicated it to George Forsythe, who was the founder of this department. Now, the book that's planned, called Selected Papers on Design of Algorithms, I had decided some time ago to dedicate that to Bob Floyd. And in fact, but right now at the moment, exactly 1 page of that book has been typeset, and it's the dedication page. And so here I'm showing you the dedication page. Can you zoom in on this? My partner in O'Grime. Now you have to look at the Oxford English Dictionary to find out that this is an old way of saying algorithm. But anyway, I looked at the at the date of the file, when I looked in my computer file, to find out when I typeset this, when I created the file, and it was September 20th, 2000, almost exactly a year before Bob's death. I certainly hope that that this, and in this book, of course, there will be reprinted the joint papers we make, and I'll be able to make some remarks in the preface about my indebtedness to Bob, and I'm hoping in this way to express some of the lasting appreciation I have, and I hope I give you some of the flavor of this in my talk this morning. Thank you.
Time for questions?
Sure, time for a few questions.
Very.
Actually, I noticed when you showed the index entry for Robert W. Floyd, you didn't expand his middle name.
This is true. This is true. In fact, one of the letters I found was but in fact I've given this is actually the complete name. So the fact that there is no period after the W. So when you have W period, that's an abbreviation for W without a period. And Bob was very fond of pointing out that people like Harry S. Truman, it was the same thing. That his middle name was something else, but he had it legally changed to W.
Okay.
Good question. Thank you.
Thank you very much, Don. Okay, so we have our break till 10:30.
Yep.
Then we'll resume at 10:30.